What's up? What's up? What's up? It's your boy, the network. Today's topic is section 3.30C, states and timers. This is a subsection in the section 3.30, describe, configure, and verify BGP peer relationships and authentication. This is a topic in the CCNP route exam. It's going to be known as the CCNP Enterprise exam come February 24th, 2020. Notice I keep time stamping these videos, but so what? I'm letting y'all know. Time is ticking. Let's go ahead and take a look at the exam blueprint to see where we came from and where we're headed. All right, this is the exam blueprint implementing Cisco IP routing. Again, this is for the CCNP route exam. We just covered the section BGP active and passive states. Today we are going to cover, well, not states. They're like, yeah, I guess they are kind of states. But today we're going to cover states and timers. These are different type of states here. After that, we are going to move on to configuring and verifying eBGP. This is external BGP. Remember, there's a difference between internal and external. I need to go back and do a video for this right here. I have one, but I just didn't like the way it turned out, so I'm going to redo that one. Anyway, the states and timers. Remember, in the last video, we talked about the TCP three-way handshake that has to occur before BGP routers become neighbors, right? Well, after the TCP three-way handshake, right, there's another state of being that these routers need to go through, or different states that these routers need to go through before they actually become neighbors. It's like being in an actual relationship, right? You have to like court the other person, right? And the other person needs to, like certain things about you and vice versa, right? So that's why we call these BGP peer relationships. It's essentially a relationship. How fitting is that, right? Let's go ahead and get to the slides for some more information here. So the BGP neighbor states, going back to what we were mentioning from the last video. Remember, there's a TCP three-way handshake that must occur, right? And if you look in this slide right here, obviously there's 6 neighbor states, right? But of those two of those 6 is part of the three-way handshake, right? So the three-way handshake occurs, and these are the states that it's in, idle and connect, right? We'll go further into detail on what each of these states are, right? So to create a neighbor relationship, a BGP router first tries to create a TCP connection, which I've said about 5 times in the past 2 minutes, right? When the connection is established, the router will send a BGP open message, right? So that open comes after the active, right? So we see where it says open sent. So we got idle. So maybe I should have made this bracket a little bit bigger to active. I had it like that, but I was like, it kind of sends the active. It gets in the active state first, then it sends the open send. But anyways, it will send a BGP open message, right, after the TCP three-way handshake is established, which is similar to a hello message. You know what a hello message is, right? In EIG, it's the hello messages that we send in EIGRP and OSPF. These are called the open messages for BGP. There's also Keepalives and other stuff like that. We'll get into that. But anyways, then the parameters are matched, and then routers become peers. There's several parameters such as hello and dead timers and things like that. We'll go into that as well. During this process, the peer will go through various stages as follows. There are 6 states: idle, connect, active, open sent, open confirm, and established. Just remember that the TCP three-way handshake occurs during idle, connect, active, and once it's active, the TCP three-way handshake connection is pretty much established. But then after that, it needs to send an open sent. It needs to send an open message to establish the BGP neighbor state. So this is basically a diagram of the states that it goes through in case something, this is more of a flow chart rather. If something goes wrong during these neighbor states, this is what happens. It basically goes back to idle if you look at this chart real quick. So it goes to idle, connect, open sent, open confirm, then established, right? If anything happens, like say, I don't know, a disconnect or ISP carrier messed up, Bright House messed up our connection, right? It's going to have an error and go back to the idle state. What's going on with Shelby over there? Dog thrown up, or sounds like it, right? So if it goes to connect, right? As you can see, we said establish. A TCP is established after the connect, right? Just like we mentioned here. So after connect, well, we don't see no active in here. Oh, there goes active. Active is when, there's another error of the TCP failed. It goes to active. That's why I didn't count it. That's why. So it goes to active if TCP failed. And if not, it will send a connect retry timeout and try again. If there's an error, it's going to go to idle. So you don't want to see idle. You don't want to see active when we do a show IP BGP. I'll show you that as well. So once TCP is established, as we mentioned before in the previous slide, it goes to open sent and then open confirm once it receives it. If we have an error, obviously we'll go back to idle, and then we will send a once the open is confirmed, it's going to receive a correct keep alive. It's going to send a hello, and then connection is the BGP neighbor state is established. If again there's an error, it goes back to idle. So again, the 6 BGP peer states or neighbor states, however you want to say it. Idle is when the BGP process is administratively down. Again, we don't want to see idle when we're in BGP. I do this a lot at work, in fact. We log into these routers, we do show IP BGP, some I know it by heart real quick, and then we look for if it says active or idle, then we know the BGP is up or not. BGP process is awaiting the next retry attempt if it's in idle. As you can see, retry goes to idle if we have an error. Once it's in connect, BGP process is waiting for the TCP connect to be established. Once it's active, the TCP connection is completed, but no messages have been sent to the peer. So once we're in active, TCP, it's not necessarily failed. It's just that TCP is established. If TCP is established, we're going to send an open message. The BGP process, again, it waits for the TCP connection to be established. And then it goes to active. TCP connect has been completed, but no BGP messages have been sent to the peer. We don't really want to see active either, but we know that at least we're halfway there. This is what we like to see. Once the open has sent TCP connect, we have a TCP, the three-way handshake has been established if we see this. And the router has sent a BGP open message. Once we know that we've sent, then we know our router is good. We don't know what's going on the other end. So the matching open message has not been received from the peer. Once we have an open confirmed, we have a lot of information here. The open message has been sent to and received from the other router. The next step is to receive a BGP Keepalive message, which is basically like a hello, to confirm that a neighbor-related parameters match, or a BGP notification message to learn that there is some mismatch in the neighbor parameters. So we see an open confirm, and we know we're pretty good here. We've gotten information from we've heard from the other router, and we've received the open message. At this point, connection most likely has been established. That's why I have it green here, and we have the happy emoticon. All neighbor parameters match, such as well, I don't think it needs to be in the same subnet, but we'll go over what the parameters are. Actually, I will do a video on that. I just gonna have to redo it. Then the peers can now exchange updates from this point on. There's also the packet types that we need to cover. After that, we're going to fire up GNS3, experiment with a little bit of that with Wireshark, and this may go over our 30-minute limit, and we're going to do a GNS3 Volt lab. Shout out to GNS3Volt.com if you want more of those topologies. So this is a BGP header, right? All we really need to pay attention to for this point as far as BGP packet types is the type field right here. This type field is either going to be a 1, 2, 3, or 4. Those 3 messages or those 4 messages are open, update, notification, and keep alive, right? Again, this decimal 1 through 4 will be in this type field right here. Open means used to establish a neighbor relationship and exchange recent parameters. This is similar to the BGP neighbor states, but these are just the messages that are being sent along with the TCP IP header. It's including the ASN and authentication values such as password and stuff like that. Update informs neighbors about new routes, withdrawn routes, and exchange routes. We could do a debug, I believe, iBGP to see all of this stuff. I'm not going to read all this to y'all, but it's basically open, update, right? The other 2 are notification, which is used to signal a BGP error, resets the neighbor relationship. So if we do a clear IP BGP star, you'll see a notification message. And then a keep alive, which is similar to a hello message, right? So a keep alive is sent every 60 seconds by default. Hold timer, which is kind of like the dead timer in eIGRP or OSPF, is basically 180 seconds or 3 times the hello or 3 times the keep alive. So this is basically like hello, and this is basically like dead timer. So hello, dead, but it's really for BGP keep alive and hold timer. They just name them differently. These are some commands we're going to kind of go over. Debug IP BGP Keepalive, that's kind of like hello messages. BGP SCAN-TIME, That's going to be something that we'll have to go over in the GNS3 Volt lab has. So I be BGP neighbors, BGP, and I believe I forgot to put one, BGP sum. I show IP BGP sum or summary. Let's go ahead and fire up GNS3. This is the link. I've been forgetting to put them in, but this is the link if you want to download this topology. Again, that's gns3volt.com. This is going to be /BGP/BGP timers. Let's go ahead and fire up GNS3 and experiment with the timers and the states. All right, so here's the lab we're going to be working with. We got router Kendrick, router Scott. Kendrick is quad 1. I believe Scott is quad 2. He's in autonomous system number 1. He is in autonomous system number 2. They're both in the 192.168.12.0 network. He is .1 again. He's .2. This is a private IP address, so don't get this. They just do this for simplicity. Let's go ahead and power these bad boys on. We're not gonna go over these steps just yet. Let's go ahead and we're gonna experiment with the neighbors states and the timers in a bit, but for now we're going to start with the neighbor states. We're going to go ahead and start a capture. Let's go ahead and start a Wireshark capture here, right? We're going to see the messages flying back and forth between these two. We're going to shut down FA, I believe this is fast Ethernet port 00, and then we're going to bring it back up and see the messages coming back and forth between the two. Actually, you know what? Now that I think about it, BGP is not set up. So let me go ahead and configure BGP between these two routers and bring us right back. Okay, so I've got BGP configured on both of these routers now. Now we're going to pull up the Wireshark capture, and then we're going to run these other steps. Now, take a look at what happened before BGP was really established. I configured BGP on Kendrick, which is the router over here, but I didn't do it on this side yet. And watch what I'm going to show you what happened, since this is a stream. This is kind of like we doing the play-by-play for Monday Night Football here. So yeah, this is a SYN, and you can see TCP kept failing here. So we got a SYN. Here goes another SYN. This is not a SYN-ACK. This is like an acknowledgement, but he has not sent a SYN-ACK to let him know that this connection is established yet. So we got these SYNs right here. Here's the acknowledgement, but they're not SYN-ACKs yet, right? So he kept going, and then finally, when I installed configured BGP on Scott right over here, we got right here what we were looking for. We got the SYN, the SYN-ACK, and then the ACK. A good way to remember the three-way handshake is kind of like SYN is like, hey, what's up? SYN-ACK is like, I'm chilling, what's up with you? And ACK is like, oh, I'm chilling. Shout out to Dewan for that. He put that on his Twitter. But anyways, so we got the SYN-ACK, ACK. Then we got the open message that we mentioned from before. What does that do? The open is used to establish a neighbor relationship and exchange basic parameters, including ASN and authentication values. We didn't have any authentication on that, but that's what would be in there. We also have, this is the open, this is the Keepalive message. What was the Keepalive again? The Keepalive is sent periodically to maintain neighbor relationship. You'll see a couple more as we go down the line there. If none are received and hold time expires, the neighbor will be considered down. The hold timer is 3 times the Keepalive. So in this case, by default, it's 180 seconds. So that's the Keepalive message. There's the update. What was the update again? Update informs neighbors about new routes, withdrawn routes, exchanged routes, used to exchange path attributes. Once we get more in depth with BGP, we'll talk about path attributes and associated network layer reachability information that use those attributes. We got a couple more Keepalives here, right? Because they're sent every 60 seconds. Here goes the couple of more acknowledgments. And once you see this red here, we know that TCP has been established here, right? So after that, we see some regular, control protocol messages, CDP. We got these loop messages, not too sure what those are. Then we got some BGP, keep alive, acknowledged. And then after that, it just keeps doing that. Keep alive, acknowledged, TCP. And it just keeps doing that every minute. Right? So that's pretty much all of those message types. Let's go ahead and discuss this activity here. So all the IP addresses have been pre-configured. I've done that. Configured eBGP between AS1 and AS2, which I've done as I cut off the video. The BGP scanner should run every 30 seconds on both sides. What's the BGP scanner? I didn't put that in our slides, but let's discuss that. So I just did a quick Google search and looked up in the Cisco community forum. So it says here, BGP scanner. Once a minute, BGP scanner walks the BGP RIB table, or routing information base, and performs important maintenance tasks. So that's what that is. But we can change that. That's one of the timers, and that's what he's asking us to do here. How do we do that? Easy. We go to routing config mode, and I believe we do BGP SCAN-TIME, and then we can change it from that point on. So, and then he says he wants us to do that on both routers. So we're going to go into Kendrick, and we're going to go to router BGP, I believe it was 1. Yeah, AS1. So we're going to say BGP SCAN-TIME, and he said he wanted us to run scan every 30 seconds on both routers. So the scan time here is listed in 5 through 60 seconds. That's for this version of iOS. So we're going to just basically run that command on both routers, and that should be for task number 1 complete. Router BGP 2, BGP scan time 60 seconds. Oh, my bad, 30 seconds. Okay, we've changed that. Next one says, ensure both routers don't wait until the next BGP advertisement interval, but send updates immediately. Let's see. That looks like it's a command, advertisement-interval, but sends updates immediately. So let's go back on Kendrick and see what we got here. Both routers. Okay, so I looked it up again. BGP advertisement interval is basically what it is. The interval at which it advertises. What do you think it would advertise? Routes, right? So by default, the BGP waits for, I believe, let me look that up real quick because I haven't even checked. Okay, so this is where we were looking for the scan interval. We changed that to 30 seconds, right? We are looking for how often it batch processes routes. So at a certain amount of time, I don't know what the default is, but at a certain amount of time, it sends a whole bunch of routes to the next router, right? He says he wants us to send updates immediately, which means we would just have to turn that feature off. And basically what we would have to do, we go to router config mode, global config first, router config BGP 1, and we're going to say neighbor, and then specify the neighbor 192.168.12.2, and right there, see where it says advertisement interval, minimum interval between sending BGP routing updates. That's basically what it is. So the minimum, he said, send updates immediately. So that means we basically got to turn this feature off. So I got out of that. Router BGP 1, and we're going to say neighbor 192.168.12.2 advertisement interval 0. So basically we got to take that command, do it twice, but we got to make sure we change the IP address. So go to Scott, change that to his neighbor is .1. That should turn it off altogether, right? So now I can't remember what show command we got to do to see that. So let's get out of this. Show IP BGP advertisement. Nope. Let's try BGP neighbors. See if that will tell us. BGP neighbors tells us a lot of information here. You can see the router ID here, how long BGP has been up, the state it's in, right? Established. We talk about what those are. See, we are looking for the advertisement interval. I don't believe that's in here. No, I don't see that in here. But anyways, the next one says when there is no activity after 15 seconds, the BGP peering should be dropped. So basically, we want to change the keep alive and basically the dead interval. I forgot what that was called again. Remember? The keep alive and the hold timer is what we're going to change here. Remember, it's 60 by default for the keep alive and 180 for the hold timer. And we can verify that again with show IP BGP neighbors. See, there it is right there. Hold time is 180, interval is 60. So we need to change those. That I remember how to do by heart. That is, so we got to go to global config mode, router config mode BGP 1, and we are, my bad, 2 on this guy, and we are going to say BGP timers, right? Isn't it IP BGP timers or BGP? Jesus, that's not it. Timers. There we go. Timers, and then BGP. That's what it is. And then right here he says the keep alive interval. So keep alive was basically hello, right? So he says no activity after 15 seconds. So that's what the dead timer we want to change to 15 seconds. Since it's 3 times that, that means the hello should be what, 5, right? So not hello, but keep alive is 5. The hold time should be 15. That's pretty much it right there. We're going to get a warning here. Hold time of less than 20 seconds increases the chances of peer flapping. We got what we needed, and we could just do a show IP BGP neighbors to verify our timers have changed. And they are now, as you can see, keep alive is 5 seconds. Minimum hold time or configured hold time is 15. Keep alive is 5 seconds. That's what we've configured. But it's not set yet, I don't believe. I think we got to clear iBGP for it to be there. So let's do that. Clear IP. This is basically resetting it. BGP star. We got to put a do there because we're in the wrong mode. That should basically reset BGP. And let's see if we do a show IP BGP neighbors and see if that changed it. Yep, and there it is. Hold time 15, keep alive, interval is 5. That is all I got for y'all today. That is my YouTube page. That is my Twitter handle. If you like what you see, please go ahead and hit that like button. Click that subscribe button if you want to see some more of this stuff. Go ahead and comment if you have any questions or if I made any mistakes, because remember, this is my learning journey. So if you see anything that I could have done to find something else or could have made this video a little quicker, go ahead and put a comment below. For now, please comment, like, subscribe to the network.